Good afternoon everyone and welcome to my YouTube channel. So here today we are looking at graphing of rational functions. So how do you graph rational functions? Let's look at some rules before we can even answer. So now under rational functions we have what we call the vertical asymptote, which is simplified as VA. This vertical asymptote is a vertical line that can be obtained by knowing the value of x. So for any equation, we know that the denominator, let's say if the denominator is x, the denominator should not be equal to 0. So in this case, x should not be equal to 0, because if x is equal to 0, it means to say we are going to have a situation of undefined. So now the vertical asymptote is obtained from equating the denominator to 0. If we have on the denominator x minus 1, we are going to equate this to be equal to 0 so that x is equal to 1. This x is equal to 1. That means to say the curve should not be able to meet this point, but it can approach it. Now, how do we find the horizontal asymptote? So the horizontal asymptote, if the power, let's say we have x raised to the power m over x raised to the power n. If m is greater than n, let's say m is equal to x to the power 3, n is equal to x raised to the power 1. Here, the horizontal asymptote does not exist. So for such type of a situation, the horizontal asymptote does not exist. So now, how about what if we only have, if m is greater than n, but it is greater than it by 1. So we can have, let's say, x raised to the power 2, the other one is just x. Now, if they have if the power difference is not that much, like the difference is just 1, we are going to have what we call a slant asymptote, which is a line like this. Now, let's say we have the power of the denominator, like as you have seen, n is on the denominator. If the power of the denominator, like n is n is greater than m, in this situation, the horizontal asymptote is equal to a 0, like that. So now let us be able to solve questions with the knowledge that we have acquired. Let's say we have this problem, y is equal to x over x plus 2. So what are we going to do here? So the first thing, let us find the vertical asymptote. So the vertical asymptote, as I said, we get the denominator, our x plus 2, equated to 0. So we have our x is equal to a negative 2. Then our horizontal asymptote, which should be equal to, horizontal asymptote should be equal to, we just get the leading powers. So this is x raised to the power 1 and this is x raised to the power 1. So we have x over x, which should be equal to a 1, like that. So we have found our vertical asymptote and our horizontal asymptote. So this one, we are going to have so this is what we have. Now our vertical asymptote is at 2. So our equation is passing somewhere here. So negative 2 is here. Then our horizontal asymptote is at 1. Let me just use a different color code. Then the horizontal asymptote is passing at 1. So we have a 1, like that. Then we are going to ask ourselves, what is the behavior of this graph as it approaches the asymptote? So our equation was saying that we have a y should be equal to x over x plus 2. So let's say we put our x value to be equal to 0. So we are going to have y should be equal to 0 over 0 plus 2, which will be just equal to 0. So for if x is equal to 0, y will also be equal to 0. So we are trying to study the behavior. Now let's say we change the value. We say that what if x is at negative 1? So x negative 1, it will be negative 1 over negative 1 plus 2, which will give us a negative 1 over a 1, which will give us negative 1. So we have negative 1. So as I go to negative 1, I'm finding that my value is equal to negative 1 as well. So I'm going to have my negative 1 is here. So my graph will pass at this point. So as long as I go this side, the graph will be moving to the left, and it won't more like be able to touch the asymptote. So we have something like this. So this is our first portion of the graph. Let us find our second portion of the graph. Let us study the behavior of this graph as we approach numbers to the left. Let's say negative 3, let's say negative 4. So when x is equal to negative 4, we are going to have for y is equal to x over x plus 2. When x is equal to, let's say, negative 3, we are going to have y should be equal to negative 3 over negative 3 plus a 2, which will give us negative 3 over, we have a negative 1, which will give us just positive 3. So this value, so let's say we know that our asymptote is at 1. Let me approximate to say at this point, this is where my 3 is. So I'll have 3 there. So I'll have a point that is here. Let me study the behavior as well as I go to negative 4. If I go to negative 4, I'll have where x is, I'll have negative 4 over, we have a negative 4 plus 2, which will be negative 4. Negative 4 plus 2 gives us a negative 2, which will give us a 2. So from this, I am able to establish that as I approach the left, so even negative 5, it will be a smaller value. So I'm going to have 4,2, which is somewhere here. So from this, I can establish the behavior of the graph. So it will be more like this. It will be going like that. So that is how we graph our graph for such type of a problem. So we have graphed that one. Let's go to our second question. Our second question is y is equal to x plus 2 over x minus 2. So same approach. Our vertical asymptote, we are going to equate the denominator to 0. So x minus 2 should be equal to 0. Our x will be equal to a 2. So when we do this, we are going to have our vertical asymptote, our horizontal asymptote. We are going to see if they are equal. We can just divide the powers. So we have x over x as our horizontal asymptote will be equal to 1, as those two letters will cancel each other. Then let us now begin graphing our graph. Let me just make it a bit straighter. So we have that. Then our asymptotes are, one is at 1, one is at 2. Let me change the color. So the one that is at 2, so x is equal to 2, occurs at this point. So the other one, which is y is equal to 1, which is our vertical asymptote, occurs at this point. So now we label them. We have a 2, we have a 1 there. Then we are going to just study the behavior of the graph as we approach the right of the graph. Let's say if I put 3, I have 2 points to assist me, 3 and 4. What am I going to have? So for 3, we are going to have for y should be equal to x plus 2 over x minus 2. So if I put 3 there, I'll have y should be equal to 3 plus 2 over 3 minus 2, which will be equal to 5 over 1. So I'm going to end up with, let's say my 5 is here. I'll have 3 comma a 5, which will be somewhere here. 3 comma a 5, which will be there. also I have a 4. If I put 4 there, what am I going to get? So we are going to put a 4. So we have 4 plus 2 over 4 minus 2, which is equal to 6 over 2, which gives us a 3. So you will realize to say, as I move to the right, my value will be decreasing. So let's say my 3 is somewhere here. Let's say my 3 is somewhere here. So I'll have that point. So these 2 points, I can connect them, and I'll have connecting them, I'll have something like this. So now this is my first portion of the graph, which will be equal to let's look at the behavior of the asymptote of the coordinates as I go to the right, to the left of the asymptote. Let's say here at 0 and here at 1. Let me begin with 1. So if I have 1, I'll put y should be equal to 1 plus 2 over a 1 minus 2, which will give me a value that is equal to 3 over negative 1, which is negative 3. So if I have 1, I'll have negative 3. Let's say my negative 3 is here. So it will be 1 comma a negative 3, which is there. And also I'll have, let's say now I use 0, so I'll have coordinates such as, so we have a 0 plus a 2 over 0 minus 2, which is 2 over negative 2, which is equal to negative 1. So I'm going to find that as I go to 0, I'll have something like, it will be passing at the point which is equal to negative 1. So in other words, as I go to the left of this graph, the value of x, it's more like it's the value of y is increasing. So this means to say we are going to do it like this. So it's passing at 1, which is here, and that point. So we have something like this. So it won't touch the asymptote, but it will be approaching it. So this is how we graph that one. So that is how we graph that problem. Let's look at our third problem. So our C is x squared minus 1 over x minus 2. So how do we solve this one? For this one, if you look at the power of the numerator, it's 2. The power of the denominator, it's 1, meaning to say we have a slant asymptote. So let us first find the vertical asymptote by equating the denominator to 0. So we are going to have x should be equal to a 2. Now the slant asymptote, so we just get the denominator and use the long division method. So we have our x squared. Now the way the powers proceed, it's x squared. Then we are going to have plus 0x. It always has to be like this, minus a 1 like that. Then we have x minus 2 like that. Then x divided by x, that gives us x times x, it gives us x squared. X times negative 2, it gives us negative 2x like that. Then we subtract this. When we subtract this, x squared minus x squared gives us a 0. 0 minus x, which it will be positive 2x like that. Then also we have a negative 1 will be dropped here. So now x divided by x, we are going to have a positive 2x divided by x. So we have 2x divided by divided by x. It will give us 2. So we have a 2 there. When we have a constant like that, we can even end there. This is just the slant asymptote that we are looking for. So when we do that, we are going to come here and say for the slant asymptote, which is saying that y is equal to x plus 2, we are going to come up with our table of values, two coordinates, are enough, our x, y, we put a 0 for x, we put a 0 for y. So we have, when I put 0 here, I'll have a 2. If I put a 0 for y, I'll have 0 is equal to x plus 2, which is negative 2 should be equal to x. So here it will be negative 2 like that. So we have so our asymptote is at x is equal to 2. So we are going to put that one. So let's approximate that x is equal to 2 at this point. So that is what we have there. Then also the asymptote is saying that to graph that one, we have a 0, 2. When x is equal to 0, y is equal to let's say a 2 is here. Then if y is equal to 0, x is equal to negative 2. So if x is equal to 0, or if y is equal to 0, x is equal to negative 2. Let's say negative 2 is here. Then all we have to do is we have to join these 2 points until they pass like that. So that is what we have for that one. Then we are going to study the behavior. So here it's negative 2. At this point, we can be able to find where the 2 coordinates meet. So you will realize to say we have 2 equations. The one that produced the slant asymptote was equal to this. We also had we also have x positive here. X is equal to 2. So where they intersect, we can just substitute for x to be 2. So we have y should be equal to 2 plus 2. Y is equal to 4. So at the point where they meet, this will be equal to a 4. So now, when we have found this, we can be able to study the behavior. Let's say I use a 3. What is the behavior of this graph? So I'll use my original graph, which was equal to y should be equal to, so putting the value for this one, it will be equal to y should be equal to, let's say I use 3, it will be 3 squared minus 1 over a 3 minus 2, which will be equal to 9 minus 1 over 1, which will just be equal to 8. So the first value will be equal to 8. So this is 3 comma. Let me just approximate to say 8 is somewhere here. Let me go to 4. If I go to 4, what is the behavior of this graph? So the behavior of this graph, if I put a 4 there, it will be equal to a 4 squared minus 1 over, we have a 4 minus 1, which will be equal to 16 minus 1 over a 3. So I'll be having, you realize to say this will be equal to a 15 over 3, which is due to space, which is equal to a 5. So 16 minus 1 is 15, divided by 3, that's 5. So 4, it will be somewhere a 5. So you will realize to say it will be 4 comma somewhere a 5. If 8 is there, then 5 should be somewhere there. So now, what is the behavior as I continue? Let's say I put a 5 there. I'll have a value such as a 5. It will be we have 5 squared minus 1 over, we have 5 minus 1, which will be equal to 25 minus 1, which will be equal to a 24 over a 4, which shall be equal to 24 divided by 4. This gives us a value of 6. So as I increase the values, the graph again begins to increase. So meaning to say at this point, the graph will go like this. So we have something like this, like that. So that is our graph at that point. Now let's see what happens as we go to the left of the asymptote. Let's say I use 1. If I replace in the original equation, I'll have 1. Y should be equal to, where there is x, I'll put 1 squared minus 1 over x which is just 1. Now without going any further, 1 minus 1 is 0, so the whole equation will be 0. So therefore this is the same as 0 comma 0. Let me see what happens to the graph as I go to, let's say, positive 1, which is here. So if I put, it is positive 1. Positive 1 is the one that is giving us a 0 at this point. Let me try to use a 0. If I use a 0, I'll have y should be equal to, we have a 0 squared minus 1 over 0 minus a 2, which will be equal to a negative 1 over negative 2, which is equal to 0.5, which is positive. So this 0.5, it shall be equal to 0.5, which is a point that is here. Let's look at our last point at where x is equal to negative 1. So when x is equal to negative 1, we are going to have, so replacing, we have our y should be equal to negative 1 squared minus 1. So you will realize to say negative 1 squared minus 1 is still equal to 0. So without finishing it, we can conclude to say it's going down. So as I go to this side, it goes down. As I go to the other side, it goes up. So I'll join my points. If I join my points, I'll have something like this. Yeah. So this is how we graph that one that has got a slant asymptote. Let's look at our last question. So for this one, we have y should be equal to 3 over x squared minus 4. So how do we solve this one? So first, let's find our vertical asymptote. Vertical asymptote should be equal to, so we have x squared minus 4. We are going to equate it to 0. So our x squared should be equal to a 4. Let's find the square root. So our x is equal to plus or minus a 2. The horizontal asymptote, since the denominator is greater than the numerator, the horizontal asymptote is at 0, like that. The horizontal asymptote is at 0. Now let's graph our graph. So we are going to have something like this. So now our asymptotes are at both negative 2 and a positive 2. So we are going to draw our asymptotes. So our asymptotes are passing at 2. So the horizontal asymptote is equal to, we have a 0 there, so it's just there. Then we are going to see the behavior as we approach, let's say a 3 and a 4 here. So if we approach these two values, what are we going to get? So if we approach here, what are we going to get? If we approach here, so this one is a bit involving. And if we also, the middle, if we approach 0, I also approach, let's say, negative 1. I also approach negative 1. Sorry, this is positive 1. What is going to be the behavior of my graph? So let's begin with the easiest one, which is 0. When y is equal to 0, we are going to have y should be equal to 3 over, or when x is equal to 0, so we have 0 squared minus 4, which will be a 3 over negative 4. 3 over negative 4 is approximately, not even approximately, it's negative 0.75. So if we have, let's say we have a 1 here, then 0.75 will be somewhere, negative 0.75 will be somewhere here. Let's go to positive 1. So positive 1, if I put positive 1 there, I'm going to have a positive 1, so it will just change to 1 minus 1 minus 4, it will give me -3, which will give me my final answer to be 3 divided by -3, it will be -1. So if I put a 1 there, it will be negative, there. Now, since this is squared, even if I put a negative number in a square, it will still be positive. So the result will be the same. The graph will also be here at this point. So we can join them. So the graph generally, as you go to the left, it decreases. As you go to the right again, it decreases. So we are going to have something like this. So it won't touch the asymptote like that. So that is what we have as our first part of the graph. Let's be able to put a 3 to study the behavior. If I put a 3 for x, I'll have where there is, so we have 3 over 3 squared minus 4, which will be 3 over, and this is 3 squared is 9, 9 minus 4 will give me 5. 3 over this one is approximately 0.6 if you do your math. Then so if I have 3, I'm going to have a 0.6. So let's say my 1 is here, then 0.6 has to be somewhere here. Then I also put a 4 and see the behavior of my graph. I'm going to find that it is going to be over 4 squared minus a 4. So you will realize to say this is 4 squared is 16 over 12. So 3 over 12 is the same as 1 over 4. And 1 over 4 is the same as 0.25. Now, so this means to say 0.25 is here. As I go to the right, my curve begins to decrease. So this means to say it won't cross the vertical asymptote. So I'll have a curve that is like this, like that. So it decreases as I go to the right. Last but not the least, let's look at the behavior as we go to the right. Now, without wasting time, the behavior as you go to the left and right is the same because the equation is protected by the squared. So even if I put -3, it will still be positive, meaning to say the result will be the same. So if I put -3, it will be a 0.6, which is here. And if I put a 4, it will still be 0.25, because if I put -3 squared, it will be positive, giving me the same thing. So to join them, I'm just going to have something like this. So this is how we graph the rational functions. Thank you very much for watching. I hope you would like, subscribe, and share for more.